So now we'll move on to part 2, how to speak MPL. And no, I will not torture you with my horrible Australian accent. So, imitating Foster's. Yeah. So now we'll just execute this top line thing and move on. We're going to import NumPy. We're going to set everything to be inline, and we'll import PyPlot. All right. In the previous part, we learned about how Matplotlib organizes plot making by figures and axes through that sort of hierarchy, that you have multiple axes to a figure and that no axes span figures, and that you learned how to make figures and do all sorts of very interesting and fun stuff. We learned about the components, what the names of the components of a figure are, and we learned how to put them all together. We learned a whole bunch of things. So my question to you is, you have all this knowledge now, what are you still doing here? You should know by now everything you need to know, right? I'm waiting for someone to say the next line.
We don't know how to control our plots and figures.
Thank you! Of course. In the previous section, we kind of just taught you about the structure and everything. We haven't told you this. We haven't told you the vocabulary of Matplotlib, and that vocabulary will let you control all those fine details, get exactly what you need for every single plot you want. And so, probably the most important part of this vocabulary is colors. Sometimes I feel like I'm talking to my 2-year-olds. We're doing colors. There are multiple ways. There are 3 general ways to specify colors in Matplotlib, and unfortunately, not all 3 ways can be used anywhere. But there are 3 general ways that you can specify colors. The first is by using a single letter character, or by name. So B means blue, G means green, R means red, C means cyan, M means magenta, Y means yellow, K means black, W means white. Way you remember that is the RGB and CMYK way of specifying things plus white. So you can specify either by a single letter or by their names. Oddly enough, green, and I think a couple other colors, if you specify it by G or you specify it by green, they're actually 2 slightly different colors. There's a really stupid reason for that. When you specify by the single letter, such as green, you're doing RGB, it will do 0, 1, 0. It will do 0 red, all green, 0 blue. So when you specify by G, you mean G. But if you specify by green, it thinks you mean the HTML version of green, which for some odd reason, I still never quite understood the HTML specification that has green be slightly blue and slightly red. I don't know. Along those lines, there are 147 other names that you can specify for colors. They're all the HTML, CSS color specifications. In addition to the 147 colors that you can specify, we also are very friendly to our English, British-speaking friends. You can say gray either G-R-E-Y or G-R-A-Y. So if you have light gray, you can say it either way. It doesn't matter. I've actually now gotten to the point where I don't even know which one is which. So, Phil, which one is which? So you can do burly wood or chartreuse or things like any of those CSS names, we recognize them and we will do those colors. You can also specify hex values as a string. So you do a string, but then you do the pound sign and then the hex values. So the first two characters for red, second two characters for green, third two characters for blue, if you're familiar with that convention. So you can specify that. You can also specify the string, not the number, the string of a floating point value between 0 and 1. And that will indicate the level of gray. So whether or not it's actually 256 shades of gray or not, but so you can do as a string 0.0, and that would mean black. So there's no whiteness to it at all. Meanwhile, a value of 1.0 as a string will mean white. And then anything in between, so string of 0.75 will be some sort of gray. The float, I don't remember the reason. There's some really deep arcane reason why we don't do the float. I think it has something to do with the scalar mappable, because if we see the number, we'll think that you're referring to some value to a color map or something like that. And so we just simply say, make it a string, and we'll know the difference. RGBA tuples. So you can specify a tuple with values between 0 and 1, either the 3 tuple or a 4 tuple. Different places may accept the 4 tuple or not. And that, or a list of those tuples, and that will work. And again, it's RGBA. So red, green, and blue, and alpha. Alpha is the transparency level. If you don't specify the transparency level, we assume that you mean no transparency. So, let's right on to our first exercise. Let's, we don't need to load it, it's there. But let's go ahead and modify this example here, this plotting example. We're plotting 3 things, one at a linear, one at to a power of 2, and one at a power of 3. And let's make it just a bunch of different colors. So let's we'll do this example together. Let's make the first one red, the second one burly wood, and the last one gray. There we go. We have 3 lines. First one was red, the second one is burly wood, and the third one is gray. I can make those colors any way I want. So I can do 0.75, right, shift enter. And so now that first line is now, that last line is now some sort of light gray. I can change this one to be 00 F, 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 and that's whatever color that would be, some sort of combination between green and blue. So again, different specifications on how to do the colors. Questions on colors? I just taught you half the vocabulary of Matplotlib right there. Move on to markers. This is a almost complete list of all the available markers in Matplotlib. There are a couple other very special markers that can be specified in a very, very special way. I'm not including that here because they're complicated. But these are the common set of markers that are available. You can have a point plus pixel. Pixel is a fun one. It's not actually a pixel in most backends, but in some backends it is. Whatever. Cross, octagon, square, pentagon. These are fun. The tick left, tick right, caret right, triangle right, try right. And then there are 4 ways to specify nothing. The string, none. The Python object, none. A string with just a space in it, and then an empty string. So you can say that you don't want a marker for something where something that by default would be a marker. And this following set of code here, this is the only place you will ever see this table. This is not in the documentation. Phil, we need to add this to the documentation. Because I never knew what the heck tick right was, or triangle, or what the heck the difference was between triangle right and try right. Now you can actually see. So triangle right, looks like a little play symbol. Meanwhile, try right is a try-pointed little symbol that points to the right. And then caret right is shifted over to the side. So that's what those symbols are. And so you can specify any of those symbols, and we shall do so in this next example. So we're going to do, as an example, we're going to try some various things. So let's do an octagon, a triangle right, and a caret down. So a string of an 8, we're going to do the triangle right, so that symbol, the greater than symbol, and then we'll do caret down, which is a value of 7, so the numerical 7. Don't ask me why these numbers or these values were chosen for what they were, but yeah. What did I do? Oh, right. Third arg must be a format. It's seeing the 7 and it's getting confused by it being the number 7. Sorry. I would have to explicitly state that it was a marker rather than, let's do a vertical line instead. So very, very difficult to see that vertical line, but if you expand it, you can see these little vertical bars for that cubic plot. And then you have the tick rights, and you have your octagon. If you were to make that really big, you would actually see that it is an 8-sided, octagon. So I could have done a pentagon by doing a P or something like that. So that's how you specify your markers. I'm sorry, what? Because it saw it saw a number and it got confused. Because it thought that I was talking about a value, like something to plot at the value of 7. So how would you would have to say, you would have to plot it out separately, like so. Plot t to the third m equals 7. No? Oh, I have to say marker? There we go. Oh, but then it added in the line style, so you have to tell it the line style is going to be. Oh, that's right, because I'm doing plot, not scatter, so yeah, it would be a line there. So, yeah, so that's why, because it saw the 7 and it's going, well, you're talking about a value here, because the call signature for plot and scatter are rather convoluted, and it's very flexible, and so it becomes ambiguous at that point with that 7 of what you mean by that 7, that numerical value of 7. So, I think that's another bug, Phil.
Seems to work on the same block.
Oh, it would. Well, yes and no. Because you specified the marker as 7, but then the specification allowed you to also specify markers for the first 2. You can only do it once. So if I wanted to have, let's say, another marker that was tick up, that's a 2, I would have to do them separately because you have to specify each one of them separately. You can't call marker equals 2 and marker equals 7 2 times in the same plot command, so you have to do them separately. So,
I assume that's also how you modify colors of the individual lines and put all those blocks on separate lines.
you don't have to. So, that's a very good question. Let's take a look at that. So I have that 8, but let's make that a red octagon, a black tick right, and color equals green for the for that carrot down. So for plot and scatter, when specifying these things, you can use a single letter representation at the shorthand. You can do a single letter representation and combine the color, the line style, and the marker. I'll get into line style next, but you can combine them only with the single letter representation of the color specification, and maybe the gray level. I think, can't remember. But I can't just simply say black. That won't work. But I can say like when mixing, you can't do that. But I can say color equals green. So when you say color equals green, you're making it explicit that, yes, I am going to be talking about a color here. And so you can then use the full color specification in any of those spots. But when you're talking about the shorthand notation, you have to keep it shorthand.
And on a related note, so when you plotted, when you're combining different plots together, it automatically goes to scatter, but when you combine your lists.
No, because so what's happening here? Because with the first plot command here, I'm giving a draw specification that's a combination of a marker and a color, but I'm omitting the line specification. It's assuming that I don't want a line, but if I wanted, I could add a line style, which I'll go into next, and it will add a line style in there. So looking between the markers, you'll see that there's a line in there. So when I omitted it from the specification, it decided not to do that. So it's not that it's going into scatter mode or not. It's just, it said, oh, you didn't tell me you wanted a line, so I'm not going to do it. It's going to do draw nothing. It's an empty string. So.
Is there
Mm-hmm.
For instance, I can't change the size.
Right. Your size can only be one size fit all. So that's why you have different ways you can call plot. So you can call plot, and some of these things that you specify will be applied to all of the things you're plotting in that call. But then if you need it to be different sizes for each one, then you would have to separate it out into separate plot calls. But they're basically equivalent. It's just a little bit different. I'm sorry.
Is there a way of specifying solid alignment versus specify the what? The symbol being filled versus not filled. For example, alignment just the outline versus filled.
Okay. So if I understand your question correctly, you're wondering if there are other symbols that I can use besides the one that I showed in that table. I'm going to say technically yes, but it's a little bit convoluted how to get to it, and I have personally never actually done it. That table that you see that I give up above, that is a built-in dictionary of marker specifications. You can actually create user-specified markers, but it wouldn't have the shorthand notation. You can't just simply give it a $sign and it will be a $sign. Although there is a couple other tricks that you might be able to do it for some symbols and such, or if let's say you wanted a theta or something like that, there's some tricks that you could get there. That's really, really advanced stuff. But you can also do user-specified markers. But this table here and the shorthand notation, the S, the P, those different values, they're all what is built in and what Matplotlib will recognize right off the bat. So. Mm-hmm. So you want the property to be different automatically?
Yeah, this run automatically. Instead of, let's say, discrete, and you probably have to run 1,000 people for that.
Okay, so you actually talk about something very near and dear to my heart. So by default, Matplotlib has a feature called color cycling, where in which it will choose a different color based on how many times you have called the plot command or the hist command or the bar command, whatever, if you don't specify the color. So, but right now, that feature is only for colors. I have been working on it for the past couple of years. I have not been able to get it to work right, except in very, very special situations, a property cycling feature, where it's arbitrary what property you want to cycle. And this was the drive for that feature that I'm working on is that I have some publications that only accept black and white figures. And I wanted to be more colorblind friendly, so I wanted my markers to cycle rather than my colors to cycle, or my line style to cycle, or the line width to change, or something like that. I wanted something else besides color to change. I've only been able to do very special situations of hard coding it in through a patch, and it doesn't even work anymore because we broke it a few other different ways. I'm working on it. I'm hoping that in the next year I'll have some sort of prototype going to at least do marker and line style cycling, but I'm hoping to get other stuff cycled as well. But then that would address your issue that you don't have to specify the line style. It would just automatically choose the next one in the cycle.
Because you have to go back and
Mm-hmm. All right. So the next section is line style, as I kind of hinted to, that there are a few different default built-in line styles. And you can also, just like with markers, you can specify custom line styles as well. But these are the few default ones. The fun thing about line styles is that there are two places that you can use line styles. One is in plotting lines. And so this table here on the left-hand column, that's how you would specify your line styles. But there are other places where you specify line styles, such as for patches, like the edges of patches, or other polygons, stuff like that. You would have to use the full name that's on the right-hand column, not the specification in the left-hand column. It's really stupid, but you can do solid lines, dash dot lines, and dotted lines, and then the three different ways that you can say nothing. A Python none object is not useful here, unlike in the markers where it can be useful. So here you'll see I have three examples where I generated, first one is solid line, second one is a dashed line, and then the third one is dash dot, not dot dash, and then I have one more dotted, so showing all four of those, and just plotted that up right here. And so, if I wanted as I kind of demonstrated earlier, if I wanted a red dashed line and a black dash dot and a yellow dotted line, I can combine these three things. I can combine the color, the line spec, and the marker spec together in these plot and scatter commands in various ways and get what I want. The one caveat is that there is a marker that is represented by a period, and then there's a line style that is represented by a dash. But there's also a line style that is a dash and a dot. Yeah, so don't try, so if you do a dash and a dot, it's going to interpret that as a line style dash and a dot. What you really mean is a dot, then a dash for the dot marker, but a solid line. So that's why it's dash dot, not dot dash. So yeah, I know, confusing. And then the example here is showing that distinction between the full name of the line style and the shorthand notation. So here I'm doing a bar plot, and I'm saying that my line style, LS, line style, is going to be dashed. I can't do dash dash as the shorthand for it here. I have to say dashed. So it's stupid, but it is what it is. Some people develop these things separately, so yeah. All right, some attributes. So what are some other things that I can mess around with in these plots? Why is this? Okay, this little bit of code here shouldn't actually be there. Anyway. So here's a table of various attributes. So you could set your alpha. You could set color or C. For those who really care, you can set your join and your cap style. So for line segments that get, you can have them either mitered or beveled or things like that. So people who really care about how their lines look joined up, especially with the dash and the dot dash style, you can make sure that everything looks nice and smooth, that it doesn't look ragged. You can set the line style, line width, the marker, you know, these are different names of things. Marker edge color, or MEC, marker edge width, or MEW, marker face color, MFC. So a marker actually has multiple components. So if you talk about marker color, it's the overall color. But if you want just the face to be one color, but then the edge to be another color, so as I demonstrated up here with this bar plot, I said that the edge color was going to be red. But then, so the edge color was going to be red, but the face color is going to be the default blue. So, at least I think that's blue. Please tell me that's blue. I can't tell. These glasses screw up my color perception completely. So that's two separate things. But if I had said just simply color, I'm sorry, I have to say color, not C. So color impacts only just that. That's stupid. Or I could have said face color, or FC. I thought it used to be the color impacted both. That's Anyway, so there's different things like that. And so just about everything in Matplotlib, anything that you can plot actually has these attributes. And actually there's some more attributes than just these, but just about anything in Matplotlib have various attributes like these that you can modify and play around with. Finally, there's the marker size, there's the visibility, a lot of times, especially for animation purposes, you might want something to be visible in one frame, but then not visible in another frame. So we have visibility set for markers, so you can hide in markers or lines or polygon, anything. And then Z order. So Z order, if you don't know what that is the Matplotlib rendering system is what I call 2.1. It's 2 dimensions plus a Z value. So you can stack your components of your plots in any order you want. And so by default, they're going to be stacked in the order that they are given. So I plot one thing and then plot another thing. You know, that second thing is going to show up on top of the first thing if they ever intersect. But you can specify the Z order, and lower values will show up. Just any floating point value, lower values, smaller values will show up below larger values that you specify. So if you want to control things like that, you can. Okay, so we're going to make a plot that has a dotted red line with large yellow diamond markers that have a green edge. Take a minute to do that. Start off with this exercise that is here right now. You're going to modify this plot command so that you're going to have a line style that is dotted. The markers are going to be diamonds and yellow. And the line is going to be red. But the markers are going to have a green edge. So there's a whole bunch of different properties to set here. Anybody still stuck? So easy. The first one is easy. You know, R and then a colon for a red dotted line. But then I say marker equals a string of a big D. Because you go back to the table up here, there were two different kinds of diamonds. There was a diamond and then there's a thin diamond. So the big D for that one, small d for the second diamond. So you want the big D. And then, so I'm saying that I want that marker, and then I'm saying that I want the face color to be yellow, and I miss out on specifying the green edge. EC, marker edge color, equals green. There I go. And if I zoom in, make this bigger, you will see that you'll have a red dotted line, yellow markers, yellow diamonds with a green edge to them. And you did all this through that plot command. Any questions? All right. Color maps. I know some people here are going to be happy to hear about this one. Okay. I think color maps are going to be the last one for this section. Oh, no, there's going to be a couple more things after that. Okay. Got to go faster. Okay. All right. Another very important property of many is the color map. As I talked about towards the end of the last section, that you use a color map, apply it to a scalar mappable, such as an image. But there are other things that can be scalar mappables as well. There are three, so besides the color map, which maps a color to a value between 0 and 1, you can also specify what color will be associated with any values that are greater than 1, and a color associated with any values less than 0, and any value that a color associated with masked values or nans or infinity goes over. So the bad values. When I say 0 to 1, associated with many color maps are the norms, the norm object that normalizes your data to a 0 to 1 range, or greater, may extend beyond 0 and 1 for certain situations. That's what the under and over is for, not for betting. So these things all work in conjunction to help control the coloring of your plots. Now, going into the default color map. The default color map is known as JET. It is an absolutely, utterly hideous color map. But this is on purpose. We want it to be absolutely hideous and ugly to force you guys to choose a color map that is appropriate for your data. We cannot choose for you a color map that makes sense, because it's impossible. If we were to choose one of the color maps for you guys that makes sense for, it only makes sense for certain types of data, but it won't make sense for others. And so then therefore there'll be other camps of data. We actually prefer to make everybody pissed off rather than only some people. It's weird, but it's also it's been the default forever. And so for us to change that default would be substantially changing, impacting existing code bases that may have assumed JET already. You can control the default for your purposes yourself in several different ways. You can either explicitly state what color map you want, in the code, or as I'll point out, there's a RC param section where you can say what the default color map is going to be. And you can also create your own color maps for your own purposes as well. Why is it? Oh, that's right. Yeah, there was this. Okay. If this is showing up on my notebook, it might not be in yours. That's okay. We'll go down to where this code segment is, and we're going to execute that. Well, it is executed for me. It's going to generate all the built-in color maps for you and organize it in a way that kind of makes sense. So we have sequential color maps. These are really good for things that are normalized. They're just simply linear organizations. That 0 to 1, some sort of intensity value that makes sense that you want, and it is not normally distributed data or something like that. There's a much more deeper explanation of it here in this docstring. Sequential, the color maps are approximately monochromatic color maps, varying smoothly between two color tones, usually from low saturation to high saturation. Sequential color maps are ideal for representing most scientific data since they show a clear progression from low to high values. Then there are diverging color maps. They have a median value, usually light in color, and vary smoothly to two different color tones at high and low values. This is good for other scientific data. Qualitative. These color maps vary rapidly in color. Qualitative color maps are useful for choosing a set of discrete colors. For example, this is one way how you can set up a set of RGB colors and stuff that you can do for determining what colors you want your line stuff. It's just an example. Another example would be land use data, where you want your color map to be, their colors be distinctly different based on what some number is for land use. And then there's the catch-all miscellaneous. So shows some sequentials stuff. By the way, for every single color map you see listed here, there's also built in a default. You can say, for example, we have binary, and you can also do binary_R for the reverse version. So you can do grays_R for the reverse version of that. Then there's another section of sequential color maps. Then these are diverging color maps. So you see that they were light in the middle, but then they have totally different color tones on either end. Qualitative ones. And then miscellaneous color maps of various types, like flag and prism. I don't know why anybody would want to use flag or prism, but they were there in MATLAB, so they're there here. So. Whenever you create a color map for yourself, it automatically gets registered in Matplotlib, so you can actually then reference that color map by name later. You don't have to actually pass in the color map object, but so all these color maps are generated on the fly in Matplotlib whenever you load it up, and that we register each one, so then you can just simply say, I want CMAP equal gray, CMAP equals cool warm, and it will use the color map that was created. So you can create your own color maps, register those names, and just refer to it by name that way. Any questions on color map? I'm not going to go into how to make your own color map. There's examples of that on the website, and we're running low on time, so. All right. Math text. So, LaTeX users rejoice. We support math text. Now, it's not a true LaTeX solution, although you can hook into the LaTeX mechanism. We can interpret math text information. So you give us a label or a string or something, and some piece of text, and you surround it with $. We will we'll parse that through ourselves, and we'll treat it like LaTeX. to a limit. We're not full latex shop here, but we can do a lot of interesting things. So, for example, if I wanted a sigma underscore I equal 15, I can do that. I surround it $signs. I do a backslash sigma and underscore to do the subscript I, and it will show up. So, so anything you would normally do in latex, math text representation, most of that stuff we can do here. One caveat is you'll usually want this R to show up. You want to put this R right before the string. Because latex, you have a lot of backslashes, and so you don't want. So if you wanted the new symbol, you're going to do \nu. Well, you don't want Python to think that you mean the carriage return and then a U. So you do an R, and it tells Python, treat this as a raw string. Don't interpret it at all. And that then gets passed down to Matplotlib, who then sees the \n and goes, \nu, you want the new symbol. So that's what that is for. So because there's so many backslashes, that it's just general practice, just put the R right before the string and you'll be fine. Any questions on that?
I put a fraction in the title.
I'm sorry, what?
I put a fraction in the title, and it's overlaying the line. It doesn't look right, and I tried using type layout.
It might. What version of Matplotlib do you have?
I forget.
Okay, there was a bug with the frac, how it was handling frac and how it was laying it out, and I think in the upcoming release we have that fixed. Yeah. If it's not fixed by the time we release 1.4, then let us know. Because I do remember working on it. Or somebody worked on it, whether it was me or not, but yeah. But a lot of those things, so yeah, things like \frac, we recognize that, and we will interpret that mostly correctly. So. All right. And then if you really, really, really do want to hook into the latex machinery, there actually is a feature to do that. I won't get into that here, but you can actually hook in to latex, and everything gets, all text gets generated through latex. So there is actually a mechanism for doing that. Annotations and arrows. So you have a plot and you want to point something out. And you say, look here. That's what an annotation is for, or an arrow is for. So to show you guys an example of an annotation. So annotate, I have the text here. I want to annotate with the text local max. It's going to be pointing to the data location 2, 1, but I'm going to place my text at 3, 1.5. So now I have, so the arrow is going to point here, but the text is going to be placed here. And I have some properties, so I can specify that I want the arrow to be black. And I want to shrink it a little bit, or something like that. I can do things like that. And I end up with this plot. So, this is just a nice, simple arrow. There's many, many kinds of arrows. And so I'll show, if you run this next segment, you can actually see what arrows are available. So there's just a nice, simple dash. There's a dash arrow. There's square brackets, there's fancy, simple, wedge. There's a whole bunch of them, and this is how you would specify them through, these different characters and do so. So, for our next exercise, we are going to we're going to modify that above example where it was pointing to the local max. I want you now to create an annotation that points to the local minimum, a local minimum, pick one, and to use a fancy red arrow. Okay? Yes?
Explain how shrink works.
What?
Explain how shrink works.
How strings work?
Shrink.
Shrink. Well, I'll just modify that value. You can see what happens with the shrink. So let's say. Hmm? Yeah, so let's make that value bigger.
Yeah, 5.75.
It really shrinks it. I don't know what the value means per se. We could do like 2.5. Yeah. So what is, if I remember correctly, it is shrinking it relative to, so anything greater than 0.5, it shrinking, and then if you do 0.75, it shrinks such that it flipped itself, and now it's growing. So then when you get to shrink equal 1, it's now the full size, but in the opposite direction. So it's centered around 0.5. So you have shrink equal 0, it's the full size pointing in the direction that you wanted, but shrink equal 1 is now full size pointing in the other direction. That makes sense? I did not come up with that, so. Okay. So at 0.5, you get this little tiny line. Because it shrunk, it collapsed in on itself, and then it inverted after that. So, all right. So go back to that example, the exercise. Anybody, so basically, just need to modify this example. So right now, the exercise has local max, so we need to change that to local min. And of course, we got to find the local minimum. Because 2.1 is not the right location. We could do negative, we can do 2.5 and negative 1. .5. 2.5 and negative 1. We'll probably need to shift over the text a bit. Let's shift it over to the 4 and put it at negative 1.5. And then we need to specify the arrow. Well, yeah, so we could first just see what this does. So right now, it's all the way over here, but because I haven't specified an arrow yet, it's not going to show me an arrow. So I got to make an arrow. So let's take a look. I can say arrow style. Arrow style equals fancy. That is one of them. And then I want the color to be red. Boom. I got a fancy red arrow. But I can do any others. So I could do that. I can do I got it backwards. Yeah, you right, shrink the arrow. Yeah, you can shrink it. So you can say shrink equals.
It's throwing an
Oh, right. There are certain arrows that do not accept the shrink argument, if I remember correctly. I can't. Yeah, arrows are a little weird. I'm not an expert with arrows. I don't do arrows that often. So are you trying to do a shrink here? Yeah, it might be that you don't do shrink there, that you have to do shrink up here. No. Okay, I'd have to look into that. Don't worry about shrink too much. It was just something that was in one of the examples, and I just went with it. But you can see how to make a red fancy arrow or whatever, and that's just nice and simple.
I have a question.
Mm-hmm.
Right now, you're hard coding a position and point the X and Y coordinates. It seems like you should be able to just specify an X value and then have the arrow point to curve at that X value. Is that possible?
Okay, so you wanted to auto-magically figure out what it is that you wanted.
Yeah. Because you want to point to the curve, right? You're not just going to point to the end of the space. So there's only one Y value at a given X value.
Patches are welcome.
Okay. Just asking, thank you.
Yeah. It's not out of the question. Yeah, it's not out of the question. It's just simply that feature had not been implemented. But also, I'll give you a counter example. What do you do when there's multiple plots? Yeah.
You don't apply it to the axis. The axis.
Well, but an axis can have multiple plots in them.
Okay.
And then what do you do for images?
What's the parent?
Hmm? Yeah, it's complicated. So in the very, very simple situations, yes, it makes perfect sense. But when you have, from a perspective of the developer, we have to think about the general cases. And that, as soon as you get into multiple plots or you get into image plots or pie plots or things like that, the whole idea falls apart. But, and I will talk about soon, you can still make extensions to this stuff. So you can make something that works well for your situation and that it makes sense to use in your situation. So, yeah.
This case, you just use the function itself. You have the function right there.
Right. Exactly. All right. Hatches is another type of property that you can set for your polygons and your patches. It's sort of a texture, something you could do with your face of your polygon. So these are the type of values, and you can mix them up, and you can repeat them to indicate a higher density of them. So in this example, we're going to mess around with one of the bars of this bar plot, and we're going to give it an X hatch. Now, let's say I want it to be X with stars. Let's say I want it to be, it's full of stars. Really, really dense stars. I repeated the asterisk 3 times, and it got more dense. So you can do these sort of textures. You can mix and combine them and all that sort of stuff. Now, as for color of these hatches, that it mostly works. Well, there's still some bugs with that, and especially in certain backends. If you're using the Mac OS X backend, we've had issues where the color of the hatch was not inherited from the bar. I've never understood it either. It's really weird, but you can set a hatch if you want. And so that's actually one of the things I want to do with the property cycling, is to cycle different hatches, because if I'm doing a black and white publication, I can't do black, white, different shades of gray. I need this one to be hatched that way, that one to be hatched this way, and stuff like that.
If you take the example of sort of local, can you do like the quadrat? Can you do a color underneath shading?
The color of...
Area underneath.
Yeah, so there was a PyPlot function that I mentioned earlier called fill between and fill. There's a bunch of fill commands, and you can give it the set of values, and it will create a polygon for you that will go below a particular thing, stuff like that. There are various functions for that. If you look in the gallery, you'll find such functions. All right. I'm going to talk about transform for a second. I'm not, no exercises or anything like that, but transforms are... My laptop was still in Eastern time. I thought it ran out of time. Transforms. So a lot of the examples I've given here, I have talked about, you specify locations such as the annotations in data coordinates. But remember, the spines, you could specify some of the spines in data coordinates, but you could also specify it in axes coordinates, stuff like that. How the heck does Matplotlib actually manage all that? And that's through something called the transform system. We have built into every figure is a hierarchy of transform objects that transforms data points from one level to the next. And so therefore we can say that we're going to position this tick label on axes coordinates this, and that way it stays there. Or on data coordinates this, but in the x direction, but it's going to be in axes coordinates in this direction. That way, no matter how I zoom and stuff, it will move along on the side, but it won't move vertically, because that's the way I want it to be. Or the legend will get placed in the upper right-hand corner. It's not going to be in data coordinates. It's going to be in axes coordinates, things like that. So we have different levels. We have the data transform. We have the axes transform. We have the figure transform, and then the screen transform. So we can communicate. If you give us a data value and you tell us some sort of value, and you tell us which transform level it is, we can transform that to any other level we want. And so this is how Matplotlib manages the positioning of all the components, is that different components have different transform levels. And so some things are relative to the screen, some things are relative to the figure, some things are relative to the axes, and some things are finally relative to the data coordinates. And that's how it works. Most of the time, you will never have to deal with this. But there are going to be times where you really, really need to control something, that it needs to go there. Now you know that there is something called the transform system, and that you can manually specify what the transforms are going to be. All right? I'm not going to go too much into it. If you guys have questions, you might want to talk about it afterwards. It's complicated, but it's very, very good. All right. Finally, the last section here before then we'll breeze our way through the last section. Managing the unmanageable, introducing Matplotlib RC. We have a default system where if you didn't specify the line style, you did not specify the color, you did not specify the line width, we will do the default thing. What that thing is whatever it is defined in this Matplotlib RC file that is stored in your home directory. There's different places where it can be. There's a lot you can do with it. It is full of all sorts of different properties that you would want. Now, for my particular setup right now, I actually don't have an RC file specified, so it's using the built-in RC file that is default, but you can have it placed in your .matplotlib directory, in your home directory, and it will always load that up and use that. But then you can also override any of that in your code. So here's an example where, forget about this line for a moment, just not worry about that. I could do mpl.rc, and I say for lines, I want to specify the line width to be 2 and line style to be --. And then note that for the plot, I'm not specifying what the line style is going to be. I'm not going to specify what the line width is going to be, so it's going to use the default. For people with older versions of Matplotlib, there's this syntax down here, mpl.rc params. That is also perfectly valid. This is a newer syntax. I think was introduced in 1.2, I think. I can't remember. Execute that. And I don't know why there's the gray background. I'm not quite sure. But you see, these two plot commands were identical. But because I changed the default in between, then that second plot got the new defaults. And so this is how you can handle styling. So if you want your default plots to have a certain style, you can modify your RC params so that, let's say, your text is always going to be large by default. Or you can say that you can specify a color cycle of your own rather than the default color cycle. You can say that your line width is always going to be, the default lines are always going to be really, really fat or something like that. You can do all of that within your RC file. This is just one small example. All right. And then there's a very nice tutorial on how to customize your Matplotlib styles at that link. Okay. We have 35 minutes left. Do we want to take a quick 5-minute break and then power through the last 30 minutes, or take a break? I'm sorry, I'm getting a mix of what? A break? 5 minutes. Be back by 11:30.